present a view. Shall I? Okay, that's weird. It's all good there. I think. Now I can see it here, but not on my screen. Sorry for the delay. I'll try to make it right in a second. Yeah. Oops. I'll try to extend my slides there, so I have a presenter view here. Yeah, now I think we're good. Okay. Hi, everyone. My name is Michael Stepankin, and I'm a security researcher at GitHub Security Lab. And in this session, I'm going to show my journey about breaking corporate Maven repositories. I'm going to speak about some interesting vulnerabilities. They're already working, these exploits, I see. So I discovered it in popular Maven repositories, and I'm going to share some interesting exploits as well. So let's get it started. This story started actually about 5 years ago when I had some Apache Solar 0 days. And as any bug hunter, I tried to find these 0 days on public bug bounty programs. And I came across a strange website called, search.maven.org. And at that time, I was able to identify an arbitrary file read on that website. And I couldn't escalate it further, but I remember a thought in my mind, a thought that if I could potentially break into the main Maven Central, whoa, okay. I think it would be my ultimate goal, because at that time I knew that Maven Central is a place where all the companies store their dependencies, and it's a huge. Can you do something about that? Yeah, okay. Okay, so at that time, I understood that Maven Central is a paramount in terms of its security, because all the companies who develop products in Java, including Google, Amazon, or Apple, they all take in their dependencies or libraries from Maven Central. So technically, if anyone can publish a malicious dependency or substitute a well-known library on Maven Central, they can easily extrapolate it to all other companies and infiltrate them this way. So my journey has been started. In this talk, I'm going to briefly talk about what is Maven and how it works. Then I'm going to talk about attack surface. And finally, I'll present some interesting attacks. So Maven is a console tool. And if you need to develop a Java application, you probably need to use some external libraries. And the standard way is to declare your libraries in a special file called pom.xml. And every dependency has a group ID, artifact ID, and version. And important information here is that it doesn't work. I'll try to rearrange some cables first. Okay, maybe that would be better. Okay. Okay, so when Maven, when we do mvn.compile, space compile command from the console line, Maven automatically resolves all these dependencies for the project, and it tries to, sorry about that. I think I'll try to connect HDMI cable directly to my computer instead of using. Yeah, maybe it's if you think about resolution. Okay, it's now good. Okay, so long story short, when we declare these dependencies in local files, Maven tries to download them from a website called repo.maven.apache.org that belongs to Maven Central Repository and hosted by a company called Sonatype. So it translates all these group ID, artifact ID, and version into HTTP request, and it basically downloads executable jar files from the external source. It also tries to download special file .pom that lists all the dependencies that this library has, so it recursively downloads all the dependencies for it as well. Then Maven stores all the downloaded libraries in special folder called .m2/repository, and they shared across all products, all local projects. So there is a number of public repositories, and Maven Central is de facto the biggest of them, but there is also a special repository for Apache, Spring, Atlassian, and JBoss products, and they all publish their artifacts into their repository instead. Maven Central is powered by Amazon S3 and behind the Fastly CDN, and the whole infrastructure is managed by the Sonatype company. But there is another website called oss.sonatype.org that basically hosts a product called Sonatype Nexus 2. And that's an open source product that a lot of companies and a lot of external developers actually upload their artifacts, and they copy it to the Maven Central. So what it basically means for attackers is that if you're able to find a vulnerability in Sonatype Nexus 2, you can exploit it and you can change any artifact into it. And these changed artifacts will be actually copied into the Maven Central and distributed among all the clients. And other repositories are basically powered by the same products. There is another product called JFrog Artifactory, which is also very popular for that, which is also, fortunately, open source. So when I researched this infrastructure, I realized that a lot of companies do not actually download their dependencies or libraries from the Maven Central directly, but they have their own in-house repositories that basically powered by the same products. And these products are installed into the corporate networks, and they store all the private artifacts that companies don't want to make public. And as a central place to download all the libraries, these products are also work as a proxies to external repository. So within the company, the typical setup is to point all the developers' machines to one of these products, and all the artifacts will be downloaded from one of these products instead of from Maven Central. So I decided to challenge myself, and I decided to ask myself, can I try to find some vulnerabilities in JFrog, in Repository, or in Sonatype Nexus? So I downloaded all the Docker images, I downloaded all the source code because they open source, and I tried to do some local setup, trying to find some vulnerabilities in them. And frankly, they're all typical Java applications that has enormous functionalities, that has different admin areas, that has some functionality to upload artifacts and download artifacts. But I had to realize that most of the functionality were hidden behind authentication. So as an external attacker, if you want to get into this, you probably won't have permissions to modify any artifacts. You will only be able to download them or take a look at their content, but not to upload or modify any data. But at the same time, there's a very special type of repository called proxy repository. And when Nexus, for example, configured to be in proxy mode, it simply takes all the requests for dependencies and translates them to Maven Central. And then when Maven Central returns the content of these dependencies, Nexus saves them into the local cache and provides them to the users. And the interesting thing about Maven proxy repositories is that they actually extend the attack surface, and they allow even unauthenticated users to upload artifacts to Maven Central and then pull them into the local repository. So when I talk about the proxy mode, it's actually not just a simple proxy mode that downloads artifact content from Maven and then returns it to the client. It actually triggers a lot of internal functionality within the application, such as expanding archive, such as parsing XML data structures, such as displaying this artifact content in the admin UI. So by simply sending a simple GET request to Nexus repository, we can actually trigger some complex operations that will be handled on the Nexus server. Sorry. So when I saw this opportunity, I immediately thought that, well, these are archives. We can upload them to Maven Central and then pull them to internal repository. So we can probably use a path traversal in artifacts name. We can probably perform a zip sleep attack when the archives are expanded. I really wanted to try XXC in POM.XML as well and some XSS vulnerabilities because the same content of artifacts is rendered in the admin console. So the very basic vulnerability I still was able to find is to actually put some JavaScript into artifact content. And two products that I tested, Repositories and Nexus, were actually vulnerable to this simple XSS issue. And when it comes to Repositories, the admin token secret, which acts like a password, were just stored in the local storage. So we can put this simple POM.XML file into the central repository and then just download to Repositories. And therefore, we can, without any permissions, we can get full stored XSS in one of these products. And when we talk about XSS, there is actually no simple solution to this problem because the artifacts content may be arbitrary, so we can't really simply escape them. And the elegant way to protect us from this attack is to actually use content security policy sandbox header that will prevent artifact rendering in browser at the same origin as the admin area. So when this header is present, the browser will consider the origin, the main name, and the port for the current artifact as null. So it cannot steal cookies or it cannot make other requests to other admin areas. And another vulnerability I found is Repositories was in the way how Repositories handles zip archives and especially Javadoc archives. And I realized that when we upload an archive on the server, Repositories by itself tries to expand it. And the archive names can also, the file names inside archives can have path traversal characters. So just by uploading a specially crafted archive to Maven Central and then downloading to Repositories, we can actually place some jar files into workspace/plugins directory. So the next time when repository will be restarted, we can actually trigger an RCE vulnerability just by providing our own jar file. And a very similar issue, I discovered another path traversal vulnerability in the repository, and it's connected how these files actually served to external user. And I figured out that when you try to download a special file from Javadoc archive, repository again just take the path to this file and tries to concatenate it to the target folder. So just by playing with URL encoding, we can actually download files not only from the archive, but from outside of the target directory. And by default, repository uses SQLite DB to store all the users' data, to store all users' names and passwords. And we can just download it and take all the username and password hashes. So these kind of basic attacks, probably an LLM can come up with something like that when you ask her to provide some attack surface. But realistically, proxy repositories are not only about that. Proxy repositories are also have a problem that I would call a name confusion attack. And name confusion attacks are way more powerful than I previously thought. So technically, when you send a GET request to the Nexus repository or to Artifactory to download an artifact, it needs to map the path values to group ID, to artifact ID, and to the version. And it may look like a simple task as a regex matching, for example. But in reality, it's way more complicated. And a simple way to kind of break, to kind of perform this attack is to use special URL encoded characters in the middle of the artifact name. For example, if we use question mark or if we use hash sign in the URL encoded form, when Nexus will take this request, it will consider the full artifact path as the artifact name. But when this request will be translated to upstream repository, for example, to Maven Central, Maven Central only returns the content that before the hash sign. So in this case, a content of artifact 1. So this would technically allow hackers to create arbitrary files with arbitrary extensions and arbitrary names on the target repository. But at the same time, this attack is highly limited because the file name should start with a specific name that exists in the upstream repository. And I actually played a lot of different configurations, and I actually tried to perform this attack to actually get something meaningful after that. And I finally find my solution. And my solution used to use just a simple semicolon character followed by the path traversal. And I managed to create a special request that starts with path to artifact 1, then followed by the semicolon and path traversal characters, and then followed by the name of artifact 2. And I realized that all 3 different projects I tested, Nexus 2, Nexus 3, and JFrog Artifactory, they all handle this path differently. So Nexus 2 will consider the whole path as artifact name, and in this case, it will be an enormous group ID. Nexus 3, on the other hand, will perform URL normalization process first. So it will consume all the path traversal characters and only consider company 2, artifact 2 as artifact name. But JFrog, on the other hand, consider everything after semicolon as path parameters. So it thinks that this path is translated to artifact 1. So how it can be exploited? For example, if a hacker sends this request to JFrog Artifactory, JFrog will translate this request to the upstream Artifactory, to the upstream server like Nexus 2 plus Cloudflare. And Nexus 2 plus Cloudflare, for example, it can be an Apache snapshots repository, will return the content of Artifact 2. And the content of Artifact 2 will be saved on JFrog instance as Artifact 1. So it really allows us to replace any artifact with another version. And if we talk about the Maven Central is built around the idea that you can publish your own package into it, but you cannot replace any other packages that belong to other users. But this type of attack completely breaks this assumption, because using this attack, you can actually publish any artifact into Maven Central and then save it as completely other artifact on JFrog Artifactory. So the next time any legitimate Maven user will try to download user artifact 1 from the JFrog repository, it actually gets content of artifact 2. So a user gets a potentially malicious artifact. So the one condition to exploit this vulnerability was actually to find upstream repository that performs this path normalization. And unfortunately, Maven Central does not do it, but Apache repository and Gitpack, for example, they do. So they're vulnerable to this attack. And frankly, it's not only about Maven. Other repositories such as NPM, Docker registry, RubyGems, or Go packages are also vulnerable to this kind of attack. And JFrog supports them all. So we can only perform these attacks against Maven repositories, but also by any other repository supported by JFrog Artifactory. So in order to demonstrate the impact and submit it in the report, I decided to take and attack a very popular artifact called isEven. This is a library from NPM that provides a single function to developers that return true if the given number is even. It has 100,000 weekly downloads, which makes it a pretty popular NPM package. And I realized that I can construct a request like that starts from .npm isEven/package.json, then followed by the path traversal, and then they followed by isauth name. And when this request is translated to the NPM package, it actually returns a content of isauth library that does quite the opposite, and that returns true when the number is odd. So at first, I thought, well, there is no idea it's going to work. There is no way it's going to work, because when NPM actually downloads this package, it should check its content. It should check the name from the request, should match the content of the package that it downloads. But it turns out that NPM client is absolutely does not make anything from it. And it just tried to download the file from this URL, save it into the node modules folder, and tries to execute its content. And in this case, I was able to target the specific JFrog Artifactory that I created and tried and managed to poison cache of isEven package with isauth package. So you can see what mess I created here. And when I actually submitted it to the JFrog bug bounty with the title, is it even or is it odd, as a high severity vulnerability, after a week, they decided to increase the severity from high to critical and give me a $5,000 bounty for that, because technically it allows to poison cache of any Artifactory out there. And by the way, the full bug bounty amount we get from it, we donated to charity, which is Cancer Research UK. I do it for work, so I don't need this money for myself. I've got a salary. Okay, Actually, when we talk about JFrog, JFrog is very complicated when it comes to parsing URLs. And there is a lot of interesting alteration you can make to URL to completely alter how JFrog returns its content. For example, you can fetch files within archives. We can use special suffix like properties to force a local redirect that may help us to kind of break the URL encoding and force a redirect in the browser or in the client. There is also some special query parameters that alter how it will make requests to the upstream proxy. For example, an alternate remote site URL. If you're able to use this parameter in your request, you can completely override the host name of the upstream repository. And there is some protection. So external users cannot use that specific parameter. But if you're able to find a way to smuggle it into the internal request, that can point JFrog to a completely different malicious repository instead of the originally defined one. So Sonatype Nexus also has special magic parameters that allows us to bypass the local cache and, in some cases, override how artifacts are returned and how they are rendered. So, and in the last chapter, I think the most interesting one is about abusing internal metadata. So, different products I tested store artifact differently. JFrog and Nexus 3 use internal database to store all the artifacts. But Nexus 2 store all of them in just file system. And along with storing the actual artifact content, it also stored some interesting files that only meant to be accessible internally. But I found a way that we can actually break this assumption, and we can break this protection and access one of these files with some specific tricks. And eventually, I found a way how to turn access to these metadata files, override them, and trigger a full RC on the Nexus repository. But the thing is that this kind of vulnerability was patched just yesterday, although I reported it like 6 months ago. So I cannot reveal full details how we can achieve RC in Nexus 2. But at least it's patched, and the interesting thing is that in order to mitigate this attack, if you're not able to apply the patch, you can just block the double / in your request, and you'll be completely safe. So I'm going to publish a full write-up with full details about this vulnerability. Well, after a couple of weeks when public repositories can actually patch it, because I don't want to really drop one-day vulnerability on the next day when it was patched officially. So takeaways. Proxy mode in Maven repositories can drastically increase the attack surface and make pre-auth vulnerabilities possible. It's especially dangerous in situations when these in-house repositories proxy to official Maven Central, where everybody can publish their packages and use them to attack local instances. Well, URL parsing is hard. There are special characters that handle it differently by different products. Also, I really wanted to find at least XXC in pom.xml handling, but it turns out that it's been properly secured. At least these companies who run these products, they have security teams, they have big budgets, they have private bug bounty programs. So at the end of the day, I found 7 highly critical CVEs in these products just by actually reading the code and understanding how it works. And of course, with playing with burps read repeater. So thank you very much for attending my presentation. If you have any questions or you're willing to offer some money for one-day exploits, please feel free to come to our stand at GitHub. I'll be there answering all your questions. Thank you.